In this lesson, we are going to take our building curves and extrude them upwards to create proxy meshes, on the surfaces of which we will instance our windows to start bringing the buildings to life. Before we do that, we need to add some additional inputs to the modifier panel and store them as attributes, similar to what we did right at the beginning with the road width attribute. This allows us to reference those values later when necessary. The first setting I want to add to the building settings is quite important. Leave the input as a float and set the subtype to factor, with a value range between 0 and 1, using a single value. This will behave similarly to the parks amount, giving us a slider that controls values between 0 and 1. You might remember back in Chapter 1, when we looked through our assets in the Window Sets section, that we had two distinct types of windows. So let us call this a / residential commercial buildings. Next, I am going to add another input, and it is going to be an integer. And this is going to be for our floors. Set it as a single value with a minimum of 1. Same increment of 1 as well. This is going to be our floors main. We are going to use a random number of floors for each building, so we have a minimum value. Let us duplicate this a few times, because we are going to need several integer values here. We want to add a floor max and a floors set. And we also want a commercial multiplier. And that is going to be a value we can multiply the number of floors by when they are commercial buildings. That way, our skyscrapers can be 2 or 3 or 4, however many times taller than our minimum and maximum floor values. And finally, I want to have a material set. This will allow us to randomly change the colors of all of our buildings, not just glass, concrete, brick, etc., and begin assigning our attributes. That is our reroute node for building curves. Select it and press Ctrl-G. To put this into a new node group, let us rename our sockets. The input is going to be building curves, both in and out. We will store named attributes, and the first one we are going to store is a Boolean, set to the spline domain. We want to make sure this is stored on the spline domain, so that we can assign an attribute to what will represent each building. Let us just go to our splines, a tab in the spreadsheet, so that we can see the attribute as it is being added. The first one we are going to add is called commercial. This will be a selection to decide whether our buildings are commercial or not. This is not going to be a random float value like we did for parks. This will be a Boolean. The value type is Boolean, and for probability, we will add a control to our input. Let us name this C/column buildings. I am going to leave the seed set to 0. You could, of course, pull this out and place it on the modifier panel if you want. But in this case, I will just leave the seed value as 0. Next, we want to store how many floors each building will have. So let us add another store named attribute. I will name this floors. This one will be an integer and should be stored on the point domain. We are going to use a random integer value for this. Let us bring in our group inputs. We will add the min, the max, and the seed inputs for the floor amount. Here, we can rename these to be floors min, floors max, and floors set. These will define the range and variation for the floor count across different buildings. We also want to multiply this value by the commercial multiplier, but only when it is a commercial building. So for the random value, let us add a multiply node, or rather, a multiply max node. What we are going to do is multiply by a switch. Set this to integer. We can just connect the output from the commercial random value, the Boolean, into our switch. We will say that when this is true, it is going to be our commercial multiplier. So let us add that to our group outputs. So, commercial multiplier. And when the condition is false, it is just going to be 1. So we will be multiplying the result by 1, and the value stays the same. Connect this into the multiply, and plug that into our floors attribute. And lastly, we want to add the different random floats for our materials. If you remember, on our concrete material, it was called random float 2+, because there was also a random float 1. How many stories on spawn let us duplicate? We are going to have random float 2. And actually, we are also going to add a random float 3, where random float 1 is connected to our brick material. Random float 2 was for our concrete, and random float 3 is plugged into our glass material. Let us add another random value, set as a float. We can leave it between 0 and 1. Take the seed and plug it into our group inputs. Rename this as material seed. Pop this into our value for our random float 1. And on our materials, I am also just going to add 1 to it. The reason for this is that if I duplicate this over and store the exact same things for our random float 2 and random float 3, if we look in our spreadsheet, each of our random floats is currently the exact same number because the seeds are the exact same. But if I just add 2 and 3 onto our random floats on the top node, the numbers are now different. We now have 3 separate random floats for each building. Come out of our node group. Let us rename this as period buildings attribute. All we need to do is plug off inputs onto the inputs of our node group. So, commercial buildings, floors min, floors max, floors set, commercial multiplier, and material seed. And let us just set some values here in our panel. Commercial buildings is 0.2. Float max is 0.5. Can leave our seed 0 for the moment, that is fine. And our commercial multiplier, we will say 3. So our commercial glass skyscrapers are going to be 3 times higher than the residential. Next, we need to start creating our building proxies. So let us add another root. Node, press Ctrl G. I am going to rename our sockets, so we have building curves. Coming in and out. Coming out, we are going to have building proxies. The way we are going to create these is by collapsing the curve into a mesh using curve to mesh, and then using the extrude mesh. Node. We do not have faces, so we need to extrude our edges. But you will see a bit of an issue here as I scroll the offset up. These are extruding in some rather bizarre ways. This is not what we want. However, on the extrude mesh node we have a purple offset socket, which means that it is a vector. So we can actually plug in a factor here to set the direction of our offset. What direction do we want to go? Well, we want to go straight up, which is going to be a vector of 0, 0, 1. Now we have these being extruded upwards, and we can just adjust that offset scale. So how much do we want to extrude upwards by? You may think that we can just take our floors and multiply that by a certain value. But that is not going to be correct. Because if you remember, when we were looking at our assets, we made all of our assets the exact same size. If I just have a look at these ones now, let me go into local view. We made all of our assets 3 by 3 meters wide and tall. That was because we want all of our faces on these proxies to be 3 by 3 meters. Which means that if we turn that off and go back to our geometry nodes, we will need to refine where that node group went. Let us tab back in. That means we cannot just offset this by the total height of the building. We need to offset it by 3. We also need to ensure that we have a 3 by 3 on the x-axis like this, so that each of these faces here can have an instance on it. So what we are going to need to do is, on our curve, we want to resample our curve by a length of 3. So now we have a face that is going to be a length of 3 and a height of 3. So how can we actually get these to be the correct height? Well, just like we did for our cutter, we can use a repeat. So we can wrap this entire function from the extrusion into a repeat zone. So let us plug our geometry into this. Mesh goes into the repeat input. as I increase the iterations, we are increasing the number of repeats. However, this is going to get very heavy very fast. Because if you take a look at our vertices, on one we have got 1.6 thousand. As I increase this, it is going to get exponentially bigger. By the time we are up to 6 floors, we are already at 50,000. That is getting quite high. And that is because we do not have a selection. So every time we are doing this repeat, we are extruding everything. So all of the vertices down here are being extruded again and again and again and again. So we need to make sure that our selection for the extrude mesh node is only the top face. So let us take our top selection and plug this into the repeat zone. What this is going to do is loop that selection back into the input of our repeat. So we can take that input here and plug it into the selection socket. Oh, everything is broken. Why is that? Well, it is because on the very first iteration coming through, we do not have anything in here. This top selection is not activated. So we do not have any selection at all to extrude. If I click this now, that works. And if we look at our spreadsheet now, we can see that the vertex count is only 5. 6K compared to the 50,000 that we had before doing this. So now, how can we make sure that the number of iterations is going to be correct? Basically, the iterations need to match our floor count. But if I try to add our floors attribute to the end of the repeat and get our floors, that is an attribute. And I cannot plug an attribute into the iterations input. That needs to be a single value. So how do we solve this? Well, just like we have done previously, we are going to wrap this whole section inside A for each element. Loop. So let us get A for each element. Node. We are going to set this to spline. Let us make a bit more space. We will put this before the curve to mesh. Make sure that the geometry generated from the repeat is placed inside. And like we did earlier, we are going to feed our attribute into the for each element loop. So now we have the floors, a value as a single element input, which means we can now plug it directly into the iterations. Now we have these proxy meshes, and they are all at different heights based on the random floor count. As I change the floor seed, you will see that the buildings all change accordingly. The one final thing I want to do before we finish this lesson is convert each of these buildings into an instance. Because when we start to instance our windows onto each of these faces, and let me just turn on wireframe so we can see it, each of these faces will become a window. But we want to ensure that there is uniformity across each building. So we are going to need to do something very similar. Wrap all of our instance generation inside A for each element. To do that, we are going to need to separate the geometry by individual buildings. And at this point, with our for each element on the mesh, we can separate by faces, but we cannot quite separate by mesh part. So instead, we are going to convert each of these buildings into an instance, because we can use A for each instance. Loop. Let us get a geometry to instance node and drop that in here. Now we have 25 instances, one for each building. Let us tab out and rename this group as period buildings floors. And in the next lesson, we are going to start instancing our windows onto our buildings.